Alright, welcome back everybody. Welcome back from your second winter break. Today we're going to look at the classwork dated 2/12/14. Hopefully you've got that in front of you. If you don't, I suggest you pause this thing and get it because I'm going to be going pretty quickly through this. We're going to start off. Keep in mind this is probably going to be two parts. There's this part one, there's going to be a part two that you can look at too. All these videos are going to be on the class website and you can look at them again. You can pause this thing if you need to, and you can look them at home. I mean, try to use them to help you best you can. Alright, so anyway, looking through the warm-up, this should be pretty basic. I'm not going to spend much time on this. I mean, hopefully you know how to reduce a fraction. We're just looking for looking for a number that goes evenly into both the top and the bottom. Today what we're going to focus on is simplifying square root radical expressions. And you dealt with square roots before, but let's talk quickly about them. What is a number that's squared? Well, basically a number squared is the number we multiply by itself. For example, 3 squared is 9. And then what's a variable squared? Well, that's a variable multiplied by itself. And then the next thing is what are you finding when you looking for a square root of a number? Well, what you're looking for is the number that is multiplied by itself that gives you that original number. For example, the square root of 25 is 5. And the reason for that is because 5 times itself, or 5 times 5, equals 25. Square root of 100 is 10 because 10 times 10 equals 100. That's what finding the square root is. The little corner here, this part right here, is called the index. And then the radical sign, you've probably heard that term before. And then the number underneath the radical sign, that's called a radicand. Alright, so if you take a look at the next part, it says, what's a perfect square? Perfect square is a number that can be expressed as a product of two equal integers. An integer is a number that you count. For example, 1, 2, 3, 4. Integers are not 0.5, 0.3, 3/4, and the numbers in the middle of the number line. So, square root of 4 is 2, square root of 16 is 4, square root of 25 is 5, square root of 100 is 10, and square root of 144 is 12. These are all perfect squares because when you take the square root of these numbers, you get an integer. That's what makes them perfect squares. Alright, so take a look at the next thing. It says we've got the fraction 3/4 and 6/8. They look differently, but do they have the same value? If you put them both in the calculator, what you're going to find out is they're both equal to 0.75. So what happens is that we can do this with fractions. We also can do it with radicals. We can take a radical and change the way it looks without changing its value. So the big question would be is, how is it we know when a square root radical expression is simplified? First, the radicand, the number under the square root, has got to have no perfect square factors other than 1. The radicand contains no fractions, and then you can't have any radicals in the denominator of the fraction. Alright, so we can use a couple properties that are going to be able to help us out with this. First one's the multiplication property, square roots. And I know that all looks a little confusing, but it's a lot simpler than it looks. It's like this. If I've got the square root of 40, I can take it apart and call it the square root of 4 times the square root of 10. The square root of 4 times the square root of 10 equals the square root of 40. And you go either way. If I take it and reverse it, for example, if I had the square root of 3 times the square root of 5, the answer would be the square root of 15. So we can use that property to help figure out how to reduce these. For example, if I look at square root of 18, I can't find the square root of it because there is not a perfect square. So what I'm going to do is I'm going to look for factors that are of 18, but I want one of the numbers to be a perfect square. So if you take a look, we can take 1 times 18, 2 times 9, or 3 times 6, and all those will get 18, but the 9 out of that group is a perfect square. So what I do is I rewrite the 18 as square root of 9 times square root of 2. And when I do that, now I've got a number that I can take the square root of. So what happens is I take the square root of the 9, and it becomes a 3. And that moves out of the radical sign, because now it's not square root anymore. But the 2, I didn't take the square root of it, so it stays under. So the square root of 18 is equal to 3 times the square root of 2. In fact, if you put that in the calculator, square root of 18, you're going to get this number right here, but then if you take 3 square root of 2, you'll get the same exact number. They look different, but they are the same value. So in number 2, we've got 12. We want to break that apart. Two numbers where one of them is a perfect square. And in this case, you can see that we can take 12 and have 4 times 3, because 4 is a perfect square. Well, I can take the square root of 4, so square root of 4 is 2. And once I've done that, it comes out from underneath the radical sign, and then the square root of 3 will stay under. So the square root of 12 is the same thing as 2 times the square root of 3. Now, number 3, the square root of 24, well, same thing. We're just looking for two numbers that we can make a 24 out of. It's going to include a perfect square. If you take a look over there, you'll see that it doesn't divide by 16, it doesn't divide by 9, it does divide by 4. So we rewrite 24 as 4 times 6. The reason I do that is so now I can take the square root of 4, pull that out of the radical, and then the 6 it'll stay under because I couldn't do anything with it. So the square root of 24 is equal to 2 times the square root of 6. Alright, so 108. That's a big one. Just keep in mind that it can't be any bigger, the factors can't be any bigger than the number itself. So you just ask yourself, start going down. A perfect square, 100, does it divide by 100? No. Does it divide by 81? No. Does it divide by 64? No. 39 or 49? No. 36? No. Just kidding. Yes. It does divide by 36. So 108 is equal to 36 times 3. Now that I've got it broken apart, I can actually do the square root of 36. The square root of 36 is 6. Once I've done that, I pull it outside the radical, and the 3 will stay underneath. Square root of 108 is equal to 6 times the square root of 3. So there's a way to do this in the calculator, especially if you get a big number. If you go to your calculator and go to y equals, and then say, for example, we're trying to find the square root of 605. Now, keep in mind, we're not going to put the square root in there. We're just going to put the number 605 in there. All right, so you put the 605 in there, and you divide by x squared. Now, what's going to happen is it's going to divide it by every number, but it's going to square every number. Now, when we go to look at the table by pushing second and graph, we can see all the different numbers that try to divide by. Now, we're looking for the biggest number that has an integer under the y column. So if you look over here, we've got a 1 and a 605, but all the rest of those are fractions. If I slide down, I'll notice that there's an 11 and a 5. Well, that means that 11 squared times 5 is equal to 605. We can write that 11 square root of 5. So you see it's kind of nice because the number in the x column, it goes on the outside, and the number in the y column, that goes under the radical. Here, take a look at this one. Try the square root of 72. Go to y equals, put 72 in there, divide by x squared. When you go to the table, you're going to see that there's several different possibilities. We got 2 times 18, we got 3 times 8. Now, keep in mind, it's not 2 times 18, it's 4 times 18. And it's not 3 times 8, it's 9 times 8. But you keep on going down until you find the biggest one. And then you can tell when you don't have to look anymore because on the y side, it'll get below 1. In this case, we've got 6, which means it's 36 times 2 is equal to 72. Well, again, I just take 6, put it on the outside, and the 2 under the inside. It's kind of a shortcut way of doing it. All right. If I'm multiplying two radicals, what I can do is simply just multiply them. Square root of 5 times square root of 8 is equal to the square root of 40. Now I can reduce that, and it'll become 4 times 10, which is going to be 2 times the square root of 10. Take a look at number 2. If I've got numbers on the inside and numbers on the outside, what I'm going to do is multiply the numbers on the outside. That's going to become a 6. And the numbers on the inside are going to be 8 times 7, 56. The numbers on the inside stay on the inside. Numbers on the outside stay on the outside. So all I've got to do now is see if that reduces. The 56 does reduce. It can go 4 times 14. So when I take the square root of 4, that 2 comes on the outside, and it should be, alright, sorry about that, it should be 6 on the outside. So when I take the square root of 4, it's going to come outside, and I multiply it times the 6 that's already out there. So it's going to be 2 times 6, or 12. The 14 will stay underneath. Alright, that's all we're going to do for right now. Part 2, we'll do the back side. So why don't you see if you can do some of these on your own, and then you can take a look at part 2, and we'll go from there.